Hey guys, I'm going to be talking to you about this cool article I found called Taking One for the Team, How Bacteria Self-Destruct to Fight Viral Infections. So to sum it up here, scientists have recently discovered some species of bacteria have this weird new immune system working for them, and it basically allows them to stop everybody from getting infected by bacteriophages. So it involves a system dubbed the CBAS system. It stands for Cyclic Oligonucleotide-Based Antiphage Signaling System. It's activated by a system of proteins called the HORMA domain, but you typically see it in mammals during meiosis to help them kind of stabilize the genome during development. So this causes the bacteria cell to lyse before the bacteriophage can begin replication within the cell, preventing it from reproducing and infecting the other members of the colony. And while this may seem like a pretty big deal, we've already made some pretty good steps to combating this and developing therapies against it. I'll get into those towards the end. So, this is how the system works. So you've got your domain proteins, and they're going to be very specifically capable of binding to products made by the bacteria itself, but not from its own DNA, from the bacteriophage's DNA. It's going to start making its products basically, and it's going to find them, bind to them, and then it's going to seek out something called a CDNTase, which is a type of nucleotidal transferase. And so the binding of these two things together, these cofactors, are going to generate a secondary messenger / activator called cyclic triadenylate, abbreviated to CAAA, and it's going to message out to NUC here, which is a nuclease that helps break down the bacterial genome and ultimately kills the cell. Now this works so well that the researchers who wrote this article cloned it into an E. coli strain that they typically use in the lab for testing phages and is usually almost completely susceptible to them. And when they cloned it in, it was almost completely unsusceptible to any bacteriophages introduced. That's just how effective this is. So how the system is going to work is you got your HORMA domain proteins that are going to bind up to those peptide groups made in the cell because of the bacteriophage. It's going to bind to them, combined with something called CDNTase, which is a type of nucleotidal transferase. And this combination is able to generate a secondary messenger / activator called cyclic triadenylate, which is abbreviated with CAAA. That's going to activate an endonuclease called NUC, which is responsible for ultimately breaking down the bacterial genome and ultimately its death. It works so well that they cloned it into an E. coli strain that they use in the lab, which typically most of the time it was completely susceptible to any kind of phage infection they introduced. And this new clone strain had almost complete and absolute immunity to any bacteriophages they introduced. So here's just a little bit of a visual representation here. We're actually able to see it under a microscope. And so we got the bacterial cell here, and it's shining all brightly with its bacterial genome inside of it. But introduce a bacteriophage and have the NUC being activated, and gets all destroyed, and cell dies. So, another chart just to kind of sum it up here, what we got going on. Bacteriophage here, going to come along and deposit its nuclear material in. And so our HORMA protein here is going to sense that, bind up with it, and it's going to combine with our CDNTase, generate that CAAA, which is going to in turn bind to our NUC nuclease here and kill that cell. So, long story short, bacteria goes, hey, can't kill me if I'm already dead. And that's how it does it. It saves the rest of the colony. So, which bacteria species are capable of enacting this immune system already? Well, a lot of them have actually already been documented to show it, but the two that are being exceptionally highlighted in these articles is E. coli and Pseudomonas aeruginosa. I'm going to talk about Pseudomonas aeruginosa here, though, because it's got a couple other things going for it here that are worth mentioning. So, it's a gram-negative bacilli, it's long and thin, it's got the single polar flagellum, keeps it motile, all that. Put it on a bat plate. It's gonna be a lot of large, flat, mostly beta hemolytic colonies here. It's got that nice shiny sheen that we've seen, and it's gonna smell like grape bubblegum and all that. A little bit of green too. Put it on a Mac. It's gonna be a non-lactose fermenter, and still gonna see that sheen going on there, and a bit of a cyan, greenish blue pigment going on too. So, in addition to all this, Pseudomonas aeruginosa, a couple things about it. It's already naturally resistant to many of the antibiotics that we have available, including our beta-lactam, so penicillin, and all those other guys. And it's even more so for the nosocomial and mucoid strains, it's found to be. It can also resist lysing from alcohol and things like hand sanitizer, making it difficult to kill that way. Usually patients are treated with ciprofloxacin whenever they're infected with it. It's the best quinolone to really have an effect. In the past, a couple of studies have been done with bacteriophage therapy, and among those, it's been found that a lot of them happen to be cystic fibrosis patients who had a really bad case of Pseudomonas aeruginosa, and they just got injected with the bacteriophages, and they turned out just fine. So when you have something like Pseudomonas aeruginosa, and it's got all of these barriers going for it, it's resistant to the antibiotics, hand sanitizer can't stop it, got a whole bunch of other stuff. And now that we've got something that's been shown to work pretty good, it's just now starting to show resistance to that too? Uh-oh. Well, allow me to introduce you then to the new and improved Pseudomonas aeruginosa. Look at him, he's already so powerful before. He's got the antibiotic resistance, he's got his alcohol resistance, he can grow in a hot tub no problem, he destroys your eye within a day. Cystic fibrosis patients bring him to their knees, and just look at him, he knows he's strong, just that arrogant grin, he's bad, his single polar flagellum too sporting on his head there. And what does nature do? He's like, hey, you know what, buddy? Have some bacteriophage immunity too. Do you just fine. Hey, no problem. Say hi to the mom for me. Yeah, it's great. No, great, good. No. Oh, now how do we fight this? Oh man. Well, good news is, in this article, the same researchers who have found this and discovered this are already working on a couple solutions here. So some strategies they have are to fine-tune bacteriophages they've already been using to better dodge and bob and weave out of that sea bass system bacteria have, or they could manufacture a drug that resembles those peptides that triggers the sea bass system and get bacteria to just kill themselves no problem like that without us having to even have bacteriophages. But you need to fully understand this first, though, because we've found over 6,000 different distinct sea bass systems out there. On the other hand, though, coincidentally, these bacteria develop these resistance to bacteriophages, but in order to make room for that in their genome, they have to give up any antibiotic resistances. So maybe in the future, we'll be seeing more susceptibility to antibiotics again as bacteriophage immunity increases. So that's the hope here. Silver lining. Thanks, guys, for listening. Have a good day.